GCF factoring. So we're going to tackle GCF factoring in terms of rational expressions, which is what our next chapter is on. You'll know you'll need to use GCF factoring usually when you see two terms, which is a binomial, like you see here, 5x plus 20. That's a binomial. There are two terms here, and they will often have something in common, usually a number or a variable, that we want to pull out and rewrite it into a factored form, which will help us with those types of problems. So here we have 5x. So I think to myself, what numbers multiply to give me 5? 5 times 1. And that's pretty much it. I do the same idea with 20. I have 1 times 20, I have 2 times 10, and I have 4 times 5. Now the largest number that they have in common is 5. That means the GCF will be a 5. I now look at the x's. There's an x right here with the 5, but there's not with the 20. So they're not going to share any x's, just the 5. So to finish writing this problem, to finish factoring it, I've taken the 5 out, and now I can basically ask myself, 5 times what gets me 5x? X does. 5 times x is 5x. Then I go 5 times what gets me 20? 5 times 4 does. And now I have factored 5x plus 20. Our next problem, we have negative 2m plus 30. So here, once again, I'm going to go with the same strategy. I'm going to ignore this negative sign for a moment and just focus on the 2 itself. Numbers that multiply to give me 2. 1 times 2. For 30, 1 times 30, 2 times 15, 3 times 10, and 5 times 6. This time, the biggest number they have in common is a 2. So I'm going to pull a 2 out. Now, once again, there's only a single m on the first term, and there's no m's with the 30, so they don't have any n's in common. But if your leading coefficient, the first number of your expression, has a negative sign, you want to pull out a negative with it. So instead of taking out a 2, I'm taking out a negative 2. Trust me on this, it's just going to make your life easier if you do that when we tackle the types of problems we will in this chapter. So now we have negative 2 times what gets me negative 2m. M will. Negative 2 times m is negative 2m. Negative 2 times negative 15 would get me positive 30. And so now I've simplified it. We'll look at one more. So here we have 3, so 1 times 3. For 12, you have 1 times 12, 2 times 6, 3 times 4. Once again, the largest number that they share is a 3. So I can take a 3 out. Now this time you'll notice that there are two x's for the first one. I have x squared, so I have an x and an x. Here, I also have an x. So they have one x in common. So I'm going to take out a single x, just like I took out a single 3, because that's what they had in common. What I'm circling is what they have in common, the biggest thing they have in common. So now I want to fill in these parentheses. 3x times what gives me 3x squared? X does. 3x times x is 3x squared. 3x times what gets me negative 12x? Negative 4. Negative 3 times negative 4 is negative 12. The x, no x, gives me an x. Now what you see here that I've been writing out is something you can actually just do in your head. So if you get really good at this, you don't really need to write out all these numbers, but if you struggle with figuring out what's the largest number that they share, this right here is a good strategy to use, but it's not necessary to actually do the problems. Let's take a look at a few other scenarios that you'll come across in this chapter when you need to use GCF factoring. So here we have negative 4x to the third plus 24x to the second. Once again, numbers that multiply to give me 4 is 1 times 4, 2 times 2. Numbers that get me 24 would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So the largest number they have in common is a 4. They also share a 2, but we care about the biggest one. This is GCF, greatest common factor. So I'm going to pull out a 4. Now, since the very first term had a negative sign, I'm going to put a negative 4 instead. Now, the very first one, I have 1, 2, 3 x's for the first term, and the second term has 2 x's. So the most x's they have in common is 2. So that's the greatest amount of x's that they share. So now I just got to fill in my parentheses. Negative 4x squared times what gets me negative 4x to the third? X does. Negative 4x squared times x is negative 4x to the third. Negative 4x squared times what gets me 24x squared? Positive 6. Negative 4x squared times a positive 6 gets me a negative 24x squared. So in reality, I need a negative 6. A negative and a negative will make a positive 24. So once again, be careful of your signs. Make sure you're getting the right signs that can make the correct numbers up here. Now this next one is written this way because many times in this chapter you're going to see things written what I would call backwards. And they're just meant to be that way to get you practice with this little skill I'm about to show you. So if it's written backwards like this, in reality what you have here is negative x plus 6. And if you go with the strategy of writing out the multiples that you see here in red, there's really a negative 1 here. So really 1 times 1, and this is 1 times 6, and 2 times 3. The biggest thing they have in common is a 1, but since the first term is a negative, it's negative 1. And so negative 1 times what gets me negative 1x? X does. Negative 1 times what gets me positive 6, then negative 6. So basically a shortcut when you see this is essentially you write a negative 1 in front and you switch the two terms. The last one here, we have an 8 and a 16. So 1 times 8, 2 times 4. For 16, we got 1 times 16, 2 times 8, 4 times 4. The largest number they have in common is an 8. So I pull an 8 out, and then I know 8 times x is 8x, and 8 times negative 2 gets me negative 16. And that's GCF factoring.